This is the final version of the ACES Gauss meter. It's a compact handheld device designed both to measure the strength and polarity of magnetic fields in real time. At the top of the device is a Hall effect sensor, where the magnetic fields are actually measured. Putting it here allows for consistent and accurate readings when bringing it close to a magnet, acting as a probe. When turned on, the AT Mega reads the voltage coming off of the output pin of the Hall sensor and outputs all the data to the OLED display. It outputs the ADC reading and then converts that to voltage, the analog voltage coming off of the pin, field shift, polarity of the magnet, field strength in millitesla, and field strength in Gauss. Another cool add-on for the project is the calibrate. If you want to set a new baseline, you can hold a magnet near it, click calibrate, and it will set that strength of the field that it was in to its baseline voltage and give you the readings off of that. This is the final device for the ACES Gauss meter, with its power and ground test points hooked up to a DMM. When the Hall sensor is fed the reference voltage of 5 volts, it should output half of that reference voltage when not in a magnetic field. When shown a north polarity magnet, that value will increase, or if I flip the magnet, it will be a south polarity magnet and it will decrease. The magnitude of this shift will be determined by the proximity to the magnet and the strength of the magnetic field. The ADC in the AT Mega will read this value in 10 bits and do the calculations for all the different data displayed on the screen. Here's a quick overview of the prototype for the project. It's a bit easier to understand than the layout for the PCB. So this is the 9-volt regulator system. It regulates down to 5 volts, which lets it be used for the AT Mega and the OLED display. The AT Mega here has a push button, which is for the reset pin, active low reset. So it is through the push button to ground or just straight to power. It's crystal and 2 capacitors with lines and lines running to the AVR ISP programming header and breakout board. Capacitor here to stabilize the voltage in the power rails to provide a better reference voltage or more even reference voltage for the Hall sensor. This is the Hall sensor with a capacitor, again another capacitor, but this time right beside the pins. A push button for calibration, and then the I2C lines here run to the AT Mega for communication with the OLED. The prototype runs the exact same way as the final device. The same code, same circuitry. When a positive polarity magnet or north pole magnet is held here, the voltage will increase, negative will decrease. Calibration is the same, and I can recalibrate it to 0. This is the code for the ACES Gauss meter. I'm going to skip over most of the simple stuff here and just explain more of the stuff more relevant to the system. This is the calibration setup. So this is the animation screen, then it takes samples, sets the baseline, and then we have the setup for the whole display. So it sets the calibration pin to a pull-up, so when the button is pressed, shows a high or rising edge. And then when you turn the thing on, this is the startup screen code. And then here is the here's the code for the 0. This is calibration. And then down here is where it takes the actual samples for the data that's put to the screen. It takes 32 samples from the Hall sensor and then bit shifts by 5 to divide by 32. And then that's the ADC reading, and then this will calculate for the voltage, and then field shift is that ADC reading subtracted by the zeroed voltage or the zeroed ADC reading to give the difference, and then calculated in Gauss, and then 1 Gauss is equivalent to 0.1 millitesla, and then these are all the different data being displayed to the screen, and then polarity is just whether the field shift is positive or negative. So overall, pretty simple. Could be more optimized, but works perfectly fine.